Alright everybody, this is our last video for today, and this is an example like number 6 on your worksheet. That's the last problem. If you missed the other videos, they should be posted on there. I've done them for 2 and number 4. And this problem is about snowfall in Ypsilanti. And it gives us, these are different numbers again like the other video, but the same process. It gives us that our mean snowfall is 60.3 inches, and that it tells us that a year of 52.1 inches of snow has a z-score of negative 1.23. And now it's asking us to find the variation. So we have to use our unknowns here, or what we do know, what we are given, to help us with this problem. So it wants us to know to find the variation. So we want to know var of x. Var of x, what is it? And so we can't really find that out using just the mean, just this 52.1 inches in a year and the z-score. But if we use them all together, if we use what we know together, we can actually solve for the variance here. So we know that a z-score, to find one, we have to know, if we know the z-score, we know the z-score, we know what the actual value is, we know our x here, and we know our mean. That just leaves our standard deviation down here that we don't know. So we now actually know our z, our x, and our mu of x, but we don't know this standard deviation. You'll remember that standard deviation is just the square root of the variance, which actually means that our variance is just our standard deviation squared. So knowing that, we can move forward with this problem and plug our values that we know into this equation. So we know that z equals negative 1.23, negative 1.23 equals, our x is 52.1, our mean is 60.3, and we're trying to solve for this standard deviation down here. We want to get this by itself since it's unknown, so what we're going to do is we're going to multiply it over here, and then we're actually going to divide this back over, so we're just going to trade spots, and we end up with our standard deviation equals 52.1 minus 60.3 over negative 1.23. That, if I do a quick calculation, is 52.1 minus 60.3 is negative 8.2 in the denominator divided by a negative 1.23 is going to be 6.66 repeating. A lot of sixes there. So now we found our standard deviation right here, but it's asking for the variation, so we need to make sure that we recognize that. We still want to know what variation of x is. So we know that now our standard deviation equals 0.6, or 6.6, sorry, there should be a 6 in there, 6.66. Repeating, we know that our variation is just the standard deviation squared, so we just square 6.666, and we find that is just, it's about 44.44 repeating. So this is our variation, and that's the solution for this first part of the problem, for part A. We used what we were given to find the one unknown that we had, and then we had to manipulate it to actually find the variation. Okay, now that we know our standard deviation, we know our variance, we want to find the probability that snows more than 67 inches. So you can do this on your calculator, fairly easy. You just want to know the probability that x, our random variable x, how much it snows, is greater than 67. That's how we'd write it. The probability that x, a random variable, that it is kind of x here, snows more than 67 inches. If you remember how to do this on your calculator, you can just press menu 552. It'll take you to your normal CDF. You can see that this is the lower bound. X is bounded on the low end by 67. So you can put 67 as your lower bound, and then your upper bound is just pick a big number. And then you can fill in your mean and your standard deviation that you just found and do it. But if you prefer to find it using z-scores, we need to figure out what that z-score is, so we'll do that over here. We have that the z of 67 equals 67 minus 60.3 over the standard deviation we found, which was 6.66. We'll just leave it at that. That is going to be equal to almost 1. 6.7 divided by 6.666. Just a little bit over 1. 1.005. 3 decimals is good. So now this is our z-score. We want to know that, so we can find the probability that x is greater than 67, which is just the same thing as finding the probability that z is greater than 1.005. You can do the same process on your calculator if you want to, using your standard normal parameters, which is mean is 0 and standard deviation is 1, or you can use your z-score table to find that out. I'm going to use a computer calculator, and we want to find the probability that it is between or greater than 67 inches, which happens to just be according to my calculator. If you get something different, it's probably because my calculator is wrong. That's just equal to 0.1574, which seems about right. If you do the same thing below, you can do the same thing on your calculator. You have 51 and 62 as your bounds here. 51 is obviously your lower bound, and 62 is your upper. If you want to use a calculator, it's perfectly fine. I'll do it by hand for the people that don't know or would prefer z-score tables. So we want to find the probability that we want to find the probability that 51 is less than or equal to x, which is less than or equal to 62. If we're using our z-scores table, we need to actually find out what the z-scores are. So we'll quick do z of 51 is 51 minus 60.3 over 6.66. That is also, if you understand what you're doing at this point, feel free to either skip ahead or just turn the video off if you know what you're doing, because I know you guys might know this by now. So we get negative 1.396. Z is 62 is going to be 62 minus 60.3 over 6.66. That's going to be 1.7 divided by 6.66, which is just 0.255. So now we have our lower bound for our z's is negative 1.396. We want our z to be greater than that, but less than this 0.255 that we found. And again, this is equal to, if you want to break it up, probability that z is less than or equal to 0.255 minus the probability that it's greater than or equal to this negative 1.396. If you do that, you'll find that your z-score is going to be, or that your probability that this event occurs is going to be 0.5193. 0.5193. So that's probability that it snows between 51 and 62 inches. Again, you can find that on your calculator, or you can use z-tables and z-scores. Finally, this problem is a little bit of a throwback to the last section of chapter 5. So we want to know the probability that snows 4 straight years less than 55 inches. And it doesn't say here, but the snowfalls we're going to assume are independent. So first of all, we need to find the probability that it snows less than 55 inches in any given year. So we find probability that x is less than 55. It's going to be equal to the probability that z is less than or equal to, it doesn't matter for these normal variables actually. So we need to find this z-score here. Do z of 55 equals 55 minus 60.3 over 6.66 is going to be negative 5.3, negative 5.3 divided by 6.66 is going to be negative 0.796 if we round. So the probability that z is less than negative 0.796, negative 0.796. If you use your calculator, you can use your z-score tables. I don't know how many of you actually just have those laying around, but negative 0.796 is 0.213. This probability is 0.213. So now we know the probability that it happens in 1 year. So any given year, there's about a 21.3% chance that it snows less than 55 inches. Since these are independent, remember we can multiply our probabilities to find what happens if they all happen together. So we know that since we can multiply our probabilities here, if we want it to snow less than 55 inches for 4 straight years, and the probability that happens once is 0.213. And we want to know if it happens 4 straight years. We raise it to the 4 because we're just doing 0.213 times 0.213 times 0.213 times 0.213. This is equal to 0.213 to the 4th power, which is 0.213 is, it's not easy doing that on your computer. A small number. I might have done it wrong. I'm not confident in this answer. But if you get this and put it in your calculator, it'll be right. I got 0.002 and some other numbers down here. But as long as you get to this, remember that for independent events, we can multiply their probabilities together to find out the probability that they all occur together 4 straight years. And that is how you want to approach problem 6. This was a bit longer, but you can jump around where you need to. And I hope that helps you guys. Looking forward to seeing you guys tomorrow. Have a great day. You guys are very, yeah, we'll keep it at that.